Now, you're probably saying, okay, if the biggest problem that companies have today is key management and reusing keys and using the same key for everything and storing keys with the data, and OTP solves that, how come nobody's rolled it out? Well, it's complex, and the reason is this. Every time you create a new message, you create a new key. So this creates a key management nightmare, and there's special mathematical properties that a key must have. There are certain entropy principles that are required so a key can't easily be broken. So it's not like you're just going to take 011110011 and just that's a good key, right? There's a lot of test, verification, and validation that has to be done. So generating keys are hard, and then storing and managing those keys are very, very difficult. So if you're just going in and storing 100 records a day, that's 100 unique keys you have to have at your disposal. Now, here's the trick. You have to have the 100 keys, and the server or the person or the entity you're communicating with has to have those same exact keys. So correlating, managing, and syncing up those keys is very, very difficult. I remember when I worked at the CIA, and this was back in early 90s, right? Different time, different place. You didn't really have tablet computers, laptops, desktops, right? Very basic computing, and they were very, very, very limited. So we would use OTP, one-time pads, but they were often manually done. And the way it worked is if you went out into the field, you were given a book, we called it booklets, that was about 100 pages, and it had spiral around all four sides. So it was very tight spiral, which means you couldn't get in the middle and look at the next key or get access to the key, right? Because if somebody could, that would be really bad. So what you would do is you would take your pad and you'd rip off the first sheet because anyone saw that. And then that key that was on the next page, you would use that key to either encrypt or decrypt a message. And the person you were communicating with on the other end had to have the same exact pad and had to keep them consistent. If they ripped off 2 or 3 pages and you didn't, and your keys got out of sync, it wouldn't be able to work anymore. And the reason why it had to be bound all the way around is because what you did is you couldn't always carry it with you. So if I came back to my room, I would go in and take electrical current and basically put it on either end to make sure that nobody cut the wire. Because if somebody cut the wire, they could get into the information inside and see what the keys were. And as long as the wires weren't cut and it was very tightly bound, it was spiral. So as you took sheets off, it contracted. So you couldn't get inside. You couldn't look at other keys. And as you can imagine, very, very manually intensive, very logistically complex, and very, very error prone, right? If somebody ripped off 2 sheets, made a mistake or anything else. Now, if you're the CIA and in the 90s, you wanted to keep your information secure and protected, you would do that. But that's not practical. Imagine if you wanted to go in and you wanted to do secure communication with your bank. You want your banking records to be encrypted. So you have to go to your bank and they're going to give you a physical one-time pad. And then you have to go in and use that code each time. You have to type it in each time. There's a really long string. And then when you go to use it the next time, you have to rip the sheets off. And you have to make sure that whoever else is doing the banking rips the right sheets off. I mean, you can just see that's not going to work, right? It's just not a feasible solution. And even though there's computer programs that would try to do that, once again, it was not a feasible solution because there wasn't an easy, systematic way to generate keys for both sides and to be able to correlate and exchange it. So while technical people understood and knew the frustration, because there was no real solution for it, nobody really talked about it. So that's why you have cases where people are using encryption, they're rolling out keys, and it's silliness. It's like you getting a safe for your house and leaving the front door unlocked and the safe open. It's giving you a false sense of security, right? So today, cryptography is failing. And it's failing because we're using the same key for all of our data and storing it in one location. And it's easy for the attacker to get and not properly protect it. So we need to go in and generate unique keys every single time for every single message, one-time pad, not store them with the data, and have an easy way to manage and roll it out. And one of the reasons I'm so excited is up until recently, we knew about the problem, technology people did, but there was no solution that we could offer to our customers. There is a solution. Figured out not only how to generate one-time pads in an easy, scalable manner, but they also figured out how to integrate it at both a consumer and a business level. So now if you're running a business, you have a way that you can communicate with other businesses to be able to generate one-time pads on the fly, utilize, manage, and make sure they're good, robust, secure keys. Which revelize an OTP, which is make it scalable, make it integratable, and make it be able to work with both clients, servers, and businesses in an easy, scalable manner. So now we have a solution to this number one problem. And the best part about using OTP or one-time pads is, even if for some reason a client mishandles, misuses, or gives somebody a key, it doesn't matter. The attackers only have one message, one entry, one component. Because the key is always changing, it's a great way to be able to minimize the risk. So to me, we've had a problem for a long time that people have been ignoring because there was no solution. Now we have a solution to one of the biggest problems out there.